Now we're ready to get down to work in terms of looking at really your first basic step in solving an engineering problem in this class. So let's go ahead and get started with identifying what kind of system do I have? Is it going to be an open system or a closed system? Okay, we're in chapter one. We're early in chapter one. We're going to talk about open systems versus closed systems. Okay, so what's a closed system? What is an open system? First thing you're going to do is read your homework problem or quiz problem or test problem, understand the words there. And the next thing you need to do before jumping into crunching numbers is figure out what type of system do I have. So here's the two types of systems we're going to have. It's one or the other of these in this class. A closed system. A closed system is a fixed mass within the system that you describe in your sketch or in what's picture that's given to you. Or an open system where you read the problem, you detect that mass is flowing into and or out of the system that you've sketched or drawn or something like that. It's as simple as that. Closed system, fixed mass. Open system, mass is flowing either in or out or both. Okay, and so just a little mental exercise as you go through, quickly scan what's shown here on my sketch on my slide. Here's a tire. Here's a residential box fan. Here's a canister of propane. Here's an industrial or a commercial pneumatic cylinder where the piston rod is sliding back and forth depending on the pressure and amount of air that's contained within the cylinder. Here's a gas turbine engine. Here's sort of a sketch, kind of a hand-drawn sketch of a classic piston and cylinder. And here's a space heater that I use in the basement. All right, so let's go through some of these. This sketch is a classic closed system piston and cylinder that would depict something that's real, a real piston and cylinder. Okay, so the key is, so here's my sketch. The next thing I did, and you're going to be doing this in your homework solutions, quiz solutions, test solutions, not only are you going to draw a sketch, doesn't need to be a work of art, but you're going to draw a sketch that depicts a piston and cylinder, but you're going to put in a little dashed line, and I've done that in red to depict, that's called a control surface. That dashed line indicates to other engineers and yourself that the system that you're going to be analyzing is the air or whatever gas is trapped inside the piston and cylinder. So you're clearly defining, this is my system, and for this situation, it's a fixed mass. It's a fixed mass of gas contained within the piston and cylinder. So what the dashed line is called a control surface that you draw. And what's inside that controlled surface, we're going to identify as a closed system. No mass coming in or out. Fixed mass. Simple as that. Okay, so here's again, same general idea. Let's say you're given an image or a sketch. Do you see that if I were trying to solve a problem there, I would draw my little dashed control surface right here, okay, because that's really what's going on here. And to depict it maybe a little better with a hand-drawn sketch, I draw a horizontal piston and cylinder, because that's the way this is arranged, sort of horizontally. And here's my dashed line to show the control surface to indicate that I've got a closed system of a gas contained within the piston and cylinder. Really very simple. We don't need to spend, oh, wow. I see my text box. It says, this is considered a closed system as long as the air or gas inlet to the system is closed and or the outlet port to exhaust air is closed. So as long as these ports are fully closed, this is a closed system. And so I guess you see the next part. If we were to somehow open one of those ports and jam more air in, and then it would be an open system. But for right now, as shown with the ports closed, we've got a closed system, piston and cylinder, and you're gonna be working on hundreds of problems that would look a lot like this. Okay, let's move on to another. This is an image of an actual Rolls-Royce gas turbofan aircraft engine. Okay, and in fact, this particular cutaway of this engine, physical engine, is in Goodwin Hall, hung up. So it's the Trent 1000 gas turbofan engine. And so do you see clearly, if I were to draw my control surface around this engine, clearly you see that there's mass flowing in, it's air going in and exhaust gas coming out. So this is clearly defined as an open system. Seems really easy, doesn't it? But you got it. You got it. This is step 0. Okay. Let's see. You see both ingoing and outgoing mass flows. What I've done is I've picked and I've taken a screenshot of an image out of your textbook and try to show maybe what a sketch would look like if this were a homework problem. So instead of the image, we're going to show here's a compressor section, the turbine section of the gas turbine engine. I'm showing that we're adding heat in the combustion chamber. And see, I'm showing an arrow in for mass flow in, mass flow out. And this dashed line, of course, is my control surface. So we're getting closer to be able to say, draw a sketch for homework problem solving down here rather than the image. Okay, let's see, a little something simpler, right? And cheaper. A residential box fan. Do you see that this box fan that I use all the time down in the basement, it's clearly an open system because what's the objective is to move air from one place to the other. It's got to be an open system. Well, how would I draw a hand-drawn sketch of this box fan? Well, I'd show sort of a rectangle and sort of in side view. I've tried to show the fan blades kind of in cross section or sort of a side view. I'm going to show electric power going into my sketch because I plug it into the wall because it's driven by an electric motor. I'm drawing my control surface dash line, and I'm showing an arrow going into the back of the box fan, air flowing in, air flowing out to keep me cool of the front of the box fan. So that would be a decent sort of hand-drawn sketch if this were a homework problem to analyze. Open system, classic open system, easy to analyze. A basic rubber tire on a wheel. Now I've got this one because when I'm teaching the class, I pass this physical tire around the class, and as one of a homework problem, I said, all right, young engineering student, could you estimate the volume of the closed system? So do you see that as long as we're not adding air or draining air of our tire, this is a closed system. How would you sketch this tire? And then how would you determine the volume of the air inside the tire? We go through a little exercise in our class of an engineer estimating the volume, right? So it's not a science project. As an engineer, how would you figure out the volume of the air contained in that tire as a closed system? I think you get the idea. And also we talk about how would you sketch the closed system if it becomes a homework problem. Okay, closed system, air in a tire, closed system. A bottle of propane or a small tank of propane when we're not using it. In other words, it's sitting on the shelf. Let's see, propane. We should know the chemical formula for propane, C3H8. If I've got some type of analysis problem, and this is going to be a classic problem in Chapter 3 to analyze what's inside that propane tank. I would just show a rigid vessel, okay, in the black. My dashed line, that's my control surface. I'm clearly showing that it's a closed system. Okay, got it. Now, if you use this, if you hook this up to your Coleman stove and you hook up a little tube to the opening in here, and you start using that propane, of course, then it would become an open system as you're using mass out of the tank. That would be an open system. But for this sketch, for this problem, closed system. Okay, something just came to me. We've come to the end of this video. A closed system. What's a closed system? Mass is fixed or constant within the control surface. Open system. Mass is either flowing into and or out of the control surface. As an aside, an open system is also called a control volume. Various engineers might use this as a synonym. A control volume is the same as an open system. And something just came to my mind. When you're solving homework problems, I trained myself when I was a student and then as a practicing engineer. Not only do I draw a sketch of my system, whether it's open or closed, I'm going to write down on my solution, the words closed system or open system, one or the other of those. I'm going to write that down on my solution, and that's going to give me some level of partial credit. When I was a student, I was always looking for partial credit, and that was one of my tricks for gaining the best partial credit I could get. So I now declare you an expert on identifying engineering problems in terms of open systems or closed systems, and a little bit on sketching there. So the next video is going to be Introduction to Thermodynamic Properties. So I encourage you to keep plugging along and keep watching these videos to help you gain your understanding as you're going along in this class. And so that's it. I guess for me, it's on to the next video.